So now we are go over note 17, which is today's class, front page E2, and I was keep emphasizing how anti-hydrogen, your E2 can only proceed with an anti-position hydrogen. How does that work? Okay, this is can be confusing. All right, I will give a specific example. It's not on your lecture notes, but I think it's a better example to show. What if you don't have anti-position? Okay. Okay. I just made up this one, okay? I will change this. Okay, if people take a picture, take a picture. It's important. Okay, take a picture of this one. If you get chance, I do want everyone to actually work on this. Okay. You good? You good? Okay. So guys, what I'm going to do? Okay. Can you see the picture? Yeah. What I'm going to do? Okay. We will go through each part of that. And later, I'm going to erase some of the bonds. So that's why I want you to take a picture. Okay? This is not going to be one question. This is going to be 3 or 4. Depends on how reactive, how creative we can change this. I want to, it's also answer your question. Table, it's, what if I erase some bond? What if I add some bond? What if it's secondary, tertiary, or something else? Are we good? Okay. I don't know what I'm going to make, so we'll deal with this one first. Okay, what do we mean by anti-position? Okay, in this part, here is a dash hydrogen. Here is a wedge hydrogen. And what else I have? There's a wedge hydrogen. Are we good? Are we good? My leaving group, checked. My small, strong base. Am I good just use SSB for small, strong base? Are we good? Okay, checked. What's carbon? What's the center carbon? Keep in mind, you're always looking for the center carbon. That's this one is bond with leaving group. It's a secondary, all right? Yeah. Okay, when we will do IR, I ask people to take a look of the table. If you still remember the table, okay? Can video see this? I'm not sure. Whatever. They're not here. I don't care. Okay. I'll add one more column, okay? The table is something like weak nucleophile, good nucleophile, small strong base, bulky strong base. Okay? If you don't know what I'm talking about, there is a video on how I draw this table. All right? The first one is M. Okay? I will still draw here. First one is M. Second one is primary on branch. Primary branch. Secondary. And tertiary. Okay? The table that's I fell halfway on last Friday. Yes, with the whole board, I was filling this. But the only one that I haven't really felt is E1 and E2. So we're going to do that today, okay?
Professor?
Yes?
I'm sorry, just double checking. The first one, is it a bond or M?
M.
M, okay.
So the first one is this one, CH3X.
Oh.
Are we good?
Yes.
That's one carbon. That's the very small substrate. Are we good? Yeah. Okay. Now, no reaction here. Okay, SN1 here, SN2, E2, E2. Okay, if you think, oh, you go very fast, there's a video on how I do this slowly, and I explain a little bit on what is, okay, your work on what are weak nucleophile, what are good nucleophile, what are small strong base, what are bulky base. We went over there are only 2 bulky base in today's class, right? There are only 2. Who are those?
And this.
Oh, LDA, okay, LDA. And tert-butyl, right? This one, right? There are only 2 bulky base in your whole 118 series. Like a common sense, if it's even bulkier than them, that's of course bulky base, right? But you probably won't see them. Are we good? All right. Anyway, you guys can bring flashcard. I'm just showing you this one. It's not because I've taught this class so many times, it's in my mind. I memorized this when I was a student because I think it's handy just to have them instead of you pull out your flashcard and start to compare. Okay, secondary. And then we'll do this so you can see how handy it is. Secondary, small strong base, secondary. Small strong base is going to do E2. Yes?
The one that's like good and then secondary, I see that you have 2.
Yes.
So does that mean it can be SN1 or SN2?
Yeah, we went over that in last week's notes.
Okay.
It's depend on the solvent.
So.
Okay? Okay. Yes. A follow-up question. Which one is SN2?
Polar aprotic.
Okay. Okay. I will do a clarification on SN1, which is only polar protic and no nucleophiles. Solvences only for SN1. Okay. Are we good? Yeah. Okay. If you don't know what is solvences, notes on last Wednesday. Okay. If you don't know what is polar protic or polar aprotic, notes probably on last Monday or, okay. Yeah. Anyway, last week's notes, okay? But it's not something we're doing here. We use this table, secondary, small strong base, E2. So you make determination on this is going to do a E2 reaction. Are people good? Okay. Then she said, there's an OH. OH is not a good living group. So you don't even think about them now. Okay? OH is not a good living. Okay. Not good living group. So I just put OH here because I know people are gonna do okay, this is what we do. Okay. You told us to do table. They will go find, okay, this is secondary. Your first step is always check if that's a good living group. Okay? If that's not good living group, it's not going to react on this side. All right? Okay. This is the hardest step, which make decision on which mechanism to go with. And we're going to find the anti-hydrogen. Where's my anti-hydrogen? We said E2, only anti. My bromo is wedged out. Who is my anti-position hydrogen? Will only be this one. Okay. I will do a different color. You also have a hydrogen here. But this hydrogen is not in anti-position with bromo. It's not going to leave. So this is not going to react. All right? This is, okay, my only anti-hydrogen to leaving group. Before we even start to draw the first arrow pushing, we already write so many things. And none of them should be in your answer box. That's why this midterm 2 will be a little bit hard. See, okay, when you are doing this in your exam, there is an answer box. none of this should be in your answer box. It's your thinking. That's why midterm 2 is hard. The hard part is make decision on which mechanism to use, which hydrogen to use to grab, okay? It's hard on thinking. Really, once you made the decision, okay, I know what to do because now my OET, which is the small strong base, is going to grab this hydrogen and kick my bromine out. Writing the mechanism itself is not hard. The hardest part is use the table to make decision on this is E2. And knowing I should not react on that red hydrogen, is this blue hydrogen, anti-position hydrogen, that should be the only reacting site. So once we do that, okay, I'll still keep this OH here, but it's not doing anything. I will still keep that dash methyl here. Okay. All right. So I have my OET bond with hydrogen. I have my bromo leave. Okay. Okay. If it's in an exam, okay? If it's in an exam, you write this, you will get probably partial point. If it's 5 points out of this, this one, because you already made correct decision on E2, but you get something wrong with the anti-precision, you probably can get 2 points out of that, okay? If you are doing something else, let me see what else we can do. If you are doing OH and then you will click this one out, okay? Like doing SN2, which is still possible because E2 and SN2 are always competing with each other. Okay, if you write OET, you can still get 2 points because that's a wrong mechanism. Yeah.
So we still have to write like the bromine and the HOET.
I write them here because they are byproducts, right?
Right, but they're not the major product.
They're not. I write them here just to keep the whole thing balanced. In the exam, you're only expect to write the major.
And where did the sodium go? It's just not.
So they're here.
But you don't need to write that.
Yeah, it's I will only ask you to write the major product. You will see 10 example on lecture 18. Okay, okay. If you write SN2, you can have 2 points. If you write react with the wrong size, you can still have 2 points. What else? What else can any wrong answer be? If you react on this OH, you get 0 points. Okay. No, that I'm comparing with how far you are from this. Okay. Yeah. Yes.
Quick question. Can you get on the dashed H right next to bromine?
Dash H.
Yeah, the dashed hydrogen. Yeah, that one. Can that count as the anti-H?
No, you need your alpha beta, right? This is alpha beta.
Okay. I see.
Beta elimination, right? Yeah.
If we did like SN2, you said it was possible, but it's just not the best option.
Yeah, it's like this one. So that's why you get partial points.
Right.
Yeah.
Okay.
Yeah. I actually think maybe I'll give SN2 a little bit higher because SN2 is possible. That this is a wrong because this is a
but it's not gonna like win. It's not like major.
yeah. I would say this probably only 1 point because this is a wrong product. You cannot do anti.
Right.
SN2 I would probably give you more because SN2 still exists. It's just the major or minor thing.
Right.
Okay. Well, I'll leave this to your TA. They will tell me what they write. If they all react with OH, well, this is just like people really don't study. Okay. All right.